design of this maybe on the left. Now if and
Hello students, welcome to my YouTube channel VRacademy. We are here to study about the different electronic subjects and we have started with digital electronics. And today's topic of discussion is multiplexer tree. Okay, so what exactly multiplexer tree is? First we have to go for the definition of multiplexer tree, and then I will tell you how to design a multiplexer tree. So what is a multiplexer tree? When we are designing a higher order multiplexer using a lower order multiplexer, then it leads to a design that is known as multiplexer tree. I mean, when we are going for any kind of higher order multiplexer. Now, higher order multiplexer means when we are going for, let's suppose, comparative. You have to be comparative while going for the design. I mean, 16:1 will be treated as a higher order multiplexer if you are designing it with the help of 4:1. Let us suppose you are designing 4:1 with 2:1. Then 4:1 will be treated as a higher order multiplexer, while 2:1 will be treated as a lower order multiplexer. So whenever we are going for such kind of process where we are designing a higher order multiplexer with the help of lower level multiplexer, then the overall design will be termed as multiplexer tree. Now, I'll be telling you about that one with the help of an example, one or two example. After that, you will be able to know how to design multiplexer tree. So the first question of discussion is design a 4:1 MUX using 2:1 MUX. So how to have an approach to this question, that is very, very important. I mean, whenever you are going for such kind of numerical of multiplexer, you have to have a proper approach. Now, what is that approach? First, you have to signify that which one is a higher order multiplexer in the given question. So it is in this question, we are finding out that 4:1 multiplexer is a higher order multiplexer and 2:1 multiplexer is a lower order multiplexer. So the first step will be to signify a higher order multiplexer. You just name it so that it will become convenient for you. So higher order multiplexer in this case is 4:1 and lower level, or you can say lower order multiplexer is 2:1. So what we need to do, we need to design this with the help of this. A higher order multiplexer need to be designed with the help of lower order multiplexer. So the very first step will be to signify which one is higher order or which one is lower order. Now once you have done that, you have to see the inputs of both of them. I mean inputs of higher order and inputs of lower order multiplexer. So input of higher order multiplexer is 4, input of lower order multiplexer is 2. So by using the inputs of both the orders of multiplexer, you need to find out how many number of lower order multiplexer is required in order to achieve the inputs of higher order multiplexer. I think it is you are able to understand it. With the help of input of a lower order multiplexer, you need to find out how many number of lower order MUX are required in order to design a higher order multiplexer. So how it will be obtained? It is just like if I will tell you to go for a length of, I mean, if I am telling you design a length of, or I'll tell you to design a line AB with the help of line PQ, and if I will ask you how many times line PQ is required in order to get line AB. So you can answer it quickly. If the length of this one is half of this one, so 2 times of PQ will be equal to AB. That is what you can say. And how you have got it? You can just write it as L. This one is 2L. So just divide this by this. I mean 2L by L, you will be able to get the number of PQ required in order to have the design of AB. Now the similar concept will be utilizing over here. I am telling you that in order to design a higher order multiplexer, the output, or we need to design this multiplexer with the help of this one. So how many of this lower order multiplexer is required for getting the inputs of a higher order MUX? It is kind of, if it is 4 and if it is 2, you will be able to get it by dividing the inputs of both of them. So if you are dividing 4 by 2, you will be able to get it as 2. That means 2 lower order multiplexer are initially required in order to achieve the inputs of higher order multiplexer. Now this is very simple. If suppose I would have told you that design a 16:1 multiplexer using 2:1 MUX. So higher order multiplexer would have been 16:1. and lower order multiplexer would have been 2:1. So if I would have asked you ki how many lower order MUX are required in order to get the higher order MUX, you must have told me ki in the initial step I require 8 number of 2:1 MUX in order to achieve the input of this one. This is the first priority. You have to achieve the input of the required MUX that you are designing. This is the first thing, first step. So if it is 4:1, we have to, because the question was of 4:1, so we'll once again move to 4:1. So tell me how many number of lower order multiplexer are required in order to achieve the input of higher order multiplexer. The answer is 2, because 4 divided by 2 is 2. So first of all, I am drawing 2 multiplexers, okay, 2 multiplexers, and definitely because we are having a ability of 2:1, so I am writing these two as 2:1. Now if it is a 2:1 multiplexer, how many select lines will be there? Only one select line. So just keep only one select line. How many inputs of this 2:1 will be there? 2. How many inputs of these 2:1 will be there? 2. I am naming this one as D0, this one as D1, this one as D2, this one as D3. Now definitely it will have one output. This will also have a output. I will name the select lines afterward. Okay. Now after having these two outputs, we have to think about the output. We have to think about the output. Now in order to design a higher order multiplexer, we have to think about input first, which we have already done, and then we have to think about the output, which is 1 over here. But in this case, I am getting 2 outputs. So whether that is the requirement of ours, we don't have that requirement. We need only one output. We don't need 2 outputs. So in order to do that, once again, we have to go for a 2:1 multiplexer. We have to go for 2:1 multiplexer. So once again, I am using a 2:1 multiplexer having only one output. Now definitely, if I am using 2:1 multiplexer, it will have one more select line and it will have only one output, that is Y. Now after that, we have to name the select lines. So this select line will be your S0 and this one will be your S1. Now since I have to design a 4:1 multiplexer, definitely we need to have 2 select lines. Definitely we need to have 2 select lines. In the first step, we are having only one select line. So there is a requirement of one more select line. And how to get that one more select line? With the help of that 2:1 multiplexer. Okay. Now you can just have an analysis. If you are keeping S equals to 0, S0 equals to 0. So if you are keeping S0 equals to 0, S1 equals to 0, that means this line will be selected and D0 will be coming as the output. Now you can ask me, sir, how we can think about if S1 is 0, S0 is 0, D0 will be selected. Now just a simple concept. If S0 is equal to 0, then out of these two lines, which line will be activated? Tell me. Definitely this line will be activated. The topmost line will be activated. And if this line is activated, so I am keeping this line. Means this MUX is not active, this MUX is active. Okay. Now if I am keeping S1 also equals to 0, then that means this MUX is not active, this MUX is active. And out of that one, if I am keeping S1 equals to 0, once again, this D0 will be coming as the output. The same thing was happening in this case of multiplexer. If you can recall from the last class, we were having such condition. If I am keeping this value equals to a simple concept, you can see it over here. Let's suppose this was my select line S0, this is D0, this one is D1, and this one is Y. So if I am keeping S0 equals to 0, then D0 will come as the output. If I am keeping S0 as 1, then D1 will come as the output. So the same concept implies over here. If I am keeping S0 equals to 0, this line will be active, and due to that, we are having D0 as the, this MUX will be active, and if S1 is 0, that means D0 will be active, and finally you will be getting D0 as the output. So similar things can be implied in order to understand how to design a higher order multiplexer using a lower order multiplexer. Now this is the first example. Now moving to the second one, if we are having a question like this, design a 8:1 MUX using 4:1 MUX. If this is the question. Now if such is the question, the first thing you have to find out which one is higher order multiplexer. This one is higher order multiplexer. This one is lower order multiplexer. So first we will think about the inputs. So how many 4:1 multiplexer is required in order to get 8:1 at the input? 2. So we'll go for those 2 4:1 multiplexer. This is the first. This one is the second one. Okay. Definitely, if it is 4:1, it will have 4 inputs, only 1 output. And if it is also 4:1, it will have 4 inputs, 1 output. And since it is a 4:1 multiplexer, it will have 2 select lines. Okay, I will have the nomenclature of these select lines later on. Okay, so it will be D0, D1, D2, D3, D4, D5, D6, D7. Okay, now once again, you have satisfied the condition of the inputs. You are getting it from 0 to 7, but you require only 1 output, and here you are having only 2 select lines. But in case of 8:1, you are having 3 select lines. So that means you require 1 more select line. So how to get 1 more select line? There is only one method. If you are getting a 2:1 multiplexer over here. So if I am using a 2:1 multiplexer, 2:1 multiplexer, 2:1 multiplexer, then we will be able to get the final output as only 1 output, and here we will have 1 more select line, and after that we'll give the nomenclature as S2, S1 and S0. So this is the final design of your 8:1 MUX using 4:1 MUX. Now sometimes it might be possible that you will be getting a question that design of 8:1 MUX using 4:1 MUX only. I mean to say, here I have used 2:1, but I have to use only 4:1. We cannot use 2:1. Then in that case, what need to be done? You can answer me, or you can tell me what need to be done. Anyone of you can tell me in the comment box. Next is, I am just repeating that question, same question. It is like design a 8:1 multiplexer, design a 8:1 MUX using 4:1 MUX only. 4:1 MUX only. So in that case, the same thing implies, the first thing is very simple. It will be 8:1, 4:1. So how many 4:1 is required at the input side? 2 4:1. So I am drawing that 2 4:1 MUX. D0, D1, D2, D3, D4, D5, D6, D7. It will start with D0, D1, D2, D3, then D4, D5, D6, D7. 2 select lines will be there over here. And the output, this is 4:1. This is also 4:1. Now, the output of this one will be single. The output of this one will be a single output. Now, it is written like we have to only use 4:1. You cannot use 2:1. That means in order to have the connection of these two, once again you need to use 4:1. So this is 4:1. Now definitely it will have 4 outputs. Okay, sorry, 4 data inputs and 2 select lines. Okay, but we know that in order to have 8:1, we have to have only 3 select lines. But here I am getting 1, 2, 3, 4 select lines. So definitely I need to do something in order to have only 3 select lines. So what I will do, I will connect these 2 lines. I will short these 2 lines, and I will tail this line as only 1 select line. So in that case, we'll have the value of these 2 select lines as either 0, 0, or it will be equal to 1, 1. Now you can ask me how it is possible, sir. Now let us suppose this is the line. Here I am giving 0. So definitely if I am giving 0, it will be distributed to both the select lines and it will give 0, 0. If I will give it as 1, then definitely 1, 1 will be given to both the select lines. No other possibilities are there because both of them are shorted. If I am giving 0, they will both have 0. If I am giving 1, they both will have 1. We cannot have 0, 0, 1, 0 or 1, 1 or like combination. We'll have only 2 combinations. Either both the select lines are 0 or both the select lines are 1. That means either this line will be active or this line will be active. So for that reason, we'll connect this to this and we will connect this to this. and these two data inputs are connected to ground. These two data inputs are connected to ground. Why these two inputs are connected to ground? Because they are not in use. And finally, we'll have only one output, and that is nothing but your Y. So this is the method by which we are designing a 8:1 MUX using 4:1 MUX only. We can have the various processes. The only thing you need to keep in your mind while designing a higher order multiplexer using lower order multiplexer is, first is the input requirement. First is input requirement, that how many lower order multiplexer are required in order to have a higher order multiplexer at the input. So for just by dividing that one, you will be able to get that. Now once you have got that, once you have got the number of inputs, after that the next thing should be considered as the select line, or next concept that should be coming to your mind, that how many number of select lines are required. Let's suppose 2 select lines are used over here. The next, how many numbers is required? 1. So you have to think about only one select line is required, therefore we have to go for 2:1. Now using that concept, you will be able to design a higher order multiplexer, and finally you have to think about output. So whenever you are going for such kind of design, 3 things are very important, very important. First one is input, how many number of lower order multiplexer is required to match the input of the higher order multiplexer, first thing. Then the second thing is number of select lines. You have to think the higher order multiplexer has definitely a higher number of select lines, so how to achieve that one. And finally, that the number of output should always be remaining 1, so final output should be, anyhow you have to keep it as 1. So if you are configuring, or if you are able to solve these 3 problems of a higher order multiplexer, you will be able to design it. So this is how we are going for a design of 8:1 MUX using 4:1. So these are the various examples. The last one of the example is designing a 16:1 multiplexer using 2:1 multiplexer. Now that is going to be somewhat knowledgeable. You have to think in a proper way. So the question is, design a 16:1 MUX using 2:1 MUX. Okay, so 16:1 using 2:1. How many, by seeing the higher order MUX and lower order MUX, how many of lower order MUX are required at the input? Answer in the comment box. What will be the answer? It is 8, so we'll go for 8 MUXes. This is the first one, second one, third one, fourth, fifth, sixth, seventh, and final one is 8th. Okay, now all of them are 2:1 MUX. All of them are 2:1 MUX. 2:1, 2:1, 2:1. All of them are 2:1 MUX. Now if they are 2:1 MUX, all of them are connected with a single select line. So therefore I am connecting all of them with a single select line. Okay, now it will have 2 inputs, so I am just taking those as the inputs. This is the first input. Second input name is D0, D1, then next D2, D3, then D4, D5, D6, D7, D8, D9, 10, 11, 12, 13, 14, and 15. Okay, now definitely it will, all of them will have only one output. All of them will have only one output. Only one output. Now once you have got only one output, so you have to, next thing that you have to think about is the number of select lines. So you have only completed one select line, and in design of 16:1 multiplexer, there are requirements of how many select lines? 4 select lines, and we are having only 2:1 MUX, nothing other than that. We don't have any availability other than that. So once again, what I will do, I will have the connection of this line and this line with a 2:1 multiplexer. Now you can ask me, sir, why you have connected these two with a 2:1 multiplexer? Because I don't have anything else other than 2:1 MUX. So I can take only 2 inputs at a time and can provide only one output. That is the only thing I can do, nothing other than that. So once again, I'll take this one. I'll take this one, connect it with a 2:1 mux. 2:1 mux. I'll take this and I'll take this, connect it with 2:1 mux. 2:1 mux. Finally, I'll take this one. Finally, I'll take this one and this one and connect them with a 2:1 multiplexer. Okay. Now, definitely, if they are interconnected, then they will have only one select line. All of them should be interconnected and they'll have only one select line. Once again, we have used only one select line because all of them are nothing but 2:1 multiplexer. So this is the second select line. Now once again, we are completing only two select lines, that is S3 and S2. The rest two other select lines are also required, that is S1 and S0. So for that, once again, we'll use the same concept and we'll have 2:1 multiplexer over here. 2:1. Why 2:1? Because we don't have anything any other thing available. So this is once again a 2:1 mux. Both of them are interconnected and definitely they'll have only one select line and that select line will be your S1. Finally, this and output of this should be interconnected and will be given to 2:1 mux to give only one output, and it will have a select line and that select line will be your S0. So now you can clearly see I am satisfying all the conditions of 16:1 select line. Because I need to design this with the help of this, that means we don't have anything else available. I mean, we don't have anything else other than this mux. So for that reason, the first criteria is to look for the input, which we have satisfied it over here. The second criteria was to look for the select lines that we have completed with the help of S3, S2, S1 and S0. And since we don't have anything else other than 2:1, we are every time connecting the output of 2:1 mux to get an output for the single one. And we are doing it repeatedly in order to get the final result. Now you can see that here we are using how many number of 2:1 mux? 8. This one is 4, this one is 2 and this one is 1. So 8, 4, 12, 2 is 14 and 1 15. So in order to design a 16:1 mux using 2:1 mux, we require 15 number of 2:1 multiplexer. And this is sometimes coming as a question, as a short question or MCQ in various examination, various GATE examination or IES examination, that how many number of mux are required, 2:1 mux are required in order to design a 16:1. Similarly, you can have the question, how many 2:1 mux is required in order to get 8:1. So that you need to think of. So while going for the design of a multiplexer tree, you have to keep only three things in the mind. The first thing is input requirement, select line requirement, and the output requirement. Output is always one that you have to take into consideration. So this is all about the multiplexer tree. You can have you can solve different number of questions. If you are finding out any doubt in that one, you can come up with that. Thank you for joining. If you have any suggestion, it is highly considerable to come up with that if you have any suggestions for altering my videos or changing my videos. Thank you.